Okay, hello guys. In this example, we would like to see how we're going to answer this question. So it is given that px is a function of 4x power 4 plus hx cubed plus kx squared minus x plus 2. So if px is divided by x minus 2 and x plus 1, they leave the remainders of 4 and 2 respectively. So if you look at the the question itself, the statement, the information is given, they're talking about technically the remainders theorem, okay, because x minus 2 is not the factor of the polynomial p, and x plus 1 is also not the factor of the polynomial p, therefore it will leave remainders. So because it leave a remainders, so the first hint would be we might try the remainder theorem. Okay, so for example, in A, determine the values of h and k. So if you have no idea of how to go with it in the first case, in the first place, so it might be very wise if you try the remainder theorem, because that is what the information has stated in the two sentences in the question statement. Okay, so let's see how that works. Okay, so let's say we want to do so for A. Okay, so for A, what the remainder theorem says, so if you have x minus 2, so what you can do, if you put p 2 where x is equal to 2, when x equals to 2, you can see that this thing is equal to 0. So you just substitute x into x equals to 2. So what you have is 2 power 4 plus h 2 power 3 plus k 2 square minus 2 plus 2. And this, it says that it leave remainder of 4, so it must be equal to 4. So by some simplification, you will see that this first equation will reduce to 8h plus 4k is equals to negative 60. Okay, now so we repeat the same process for another factor here. So we're going to substitute x equal to negative 1 so that the thing vanish. So if p equals to negative 1, x equals to negative 1, we substitute here. Okay, so just repeat the same process here with different value of x. So this one will be equal to 2. So doing that, you will see that eventually k is equals to 1 plus h. Okay, so with this one equation, with this equation 1, okay, and equation 2 here, so you can solve this simultaneously to give you solve simultaneously. So let me just completely do it. Okay, so hash plus 4 1 plus h equals to 4. So h eventually will be equal to negative 16 over 3, and k is equals to negative 13 over 3. So that is what you get, okay, by using the information given from the question. So if you have no idea, always look at the what information have been given in the questions. So what concept or lesson that you have learned in class, so apply that first. Sometime we might not know. I mean, there's no way that every time you will see that, oh, this is definitely will work. So it's always sometimes we can say that you need to be wise of your method choose. Okay, so in this case, always reflect what are the informations given, what we have been dealing with in class, and how we go about it and try that out. Okay, so let's do B. Okay, so in B, you want to express P as in the form of that. So what does it mean by this sentence? So if you look at this sentence, okay, it means that you want to write down Px equals to x squared minus x minus 2 qx plus rx, where q is a quadratic and r is a linear. So what is this actually? This is saying this quadratic factor multiplied by a quotient plus a remainder. So this is the remainder. Okay, this is the remainder. Your remainder is in the linear form. Okay, you will get the polynomial. So if you ask me, or if I ask you, what are the lesson in class that we have done in finding the quotient and remainder? So I hope you can answer that, which is the long division. So because of that, you should try long division, because when you talk about quotient and remainders, you should be able to relate back to what you have done in class, which is long division, because long division produce quotient. If the divisor, which is in this case x squared minus x minus 2, is a factor, then you don't have the r. So if it is not, then it will produce the r. So let's see how we do the long division. Okay, so I'm going to write down x squared minus x minus 2. So the polynomial p, which is p 4x power 4 16 over 3 x cubed minus 13 over 3 x squared minus x plus 2. So because the first term is in power 4 and your first term in the divisor is 2, so you should be multiplying by 4x squared. So if you multiply by 4x squared, what you have is 4x power 4 minus 4x cubed minus 8x squared. Okay, so if you subtract that, okay, you will have negative 4 over 3 x cubed plus 11 over 3 x squared minus x. Okay, so because this x is coming down here, so you need to multiply by negative 4 over 3x, which is the similar coefficient to this part, so that it can be reduced to 0. Okay, so you're going to have the same value here, which is negative 4 over 3 x cubed plus 4 over 3 x squared plus 8 over 3x. Okay, so I'm going to continue with the next page. So let me add a new page. Okay, so I'm going to add a new page. So what we have just now is okay, so we have x squared minus x minus 2, then you have 4x4 minus 16 over 3 x cubed minus 13 over 3 x squared minus x plus 2. So again, as we have 4 4x square here minus 4 over 3x, right? So what we have so far is 4x power 4 minus 4x cubed minus 8x square. So if you subtract that, what you have is negative 4 over 3x cubed plus 11 over 3 x square minus x, which is, I said, you bring this down. Okay, so now when you multiply by negative 4 over 3, what you have is the same, negative 4 over 3x cubed plus 4 over 3x square plus 8 over 3x. So when you minus that, you're going to have 7 over 3x square minus 11 over 3x plus 2. Now the 2 comes in. So again, so in order to get rid of this, okay, so you have to multiply by the same value. So if you multiply by the same value, so you should multiply by plus 7 over 3. Okay, because you just multiply by 7 over 3, 7 over 3 multiplied by x square here, you have 7 over 3 square, sorry, x square minus 7 over 3x minus 14 over 3. So you subtract, you will have negative 4 over 3x plus 20 over 3. So we already found your r. So this is your rx and this is your qx. So what we do, we take this, we multiply by the quotient plus the remainder, which equivalent to px. So px is equivalent or equals to x square minus x minus 2. So what is your q? Your q is 4x square minus 4 over 3x plus 7 over 3 plus your remainder, which is negative 4 over 3x plus 20 over 3. So this is your qx and this is your rx. Okay, so that is for question B. Okay, that is for question B. Now we left with question C, which is show that q is positive for all values of x and deduce the minimum value of q. Well, this part C is really testing on your form 4 additional mathematics knowledge, because q is quadratic. We have seen that q is quadratic over there. So in quadratic, this part of the question saying the qx is positive for, show that is positive for all values. So if you still remember, this indicates that you need to show that it is above the x-axis. Okay, so that is what it means. So it means by picture it must be like that, so always positive. Okay, if you have crossed the x-axis, there's a region here which is negative, so all positive, that means it must be above the x-axis. Okay, and deduce the minimum value. To deduce the minimum value, there are two ways, which is you can use the completing square, or differentiation. Okay, but in Max T, differentiation is in second semester, so we stick to completing the square. So let's do, so for to tackle C, you have to do two things. First is show that it is above the x-axis. Secondly, completing the square and show the minimum value of Q. Okay, let's do that. Okay, so I'm going to add another page here for part C. So just add another page here. Alright, now in part C, how do we complete the square? Sorry, to show that it is always positive. First, you know that Q is given by 4. So what is Q? Qx is equals to 4x squared minus 4 over 3x plus 7 over 3. Okay, so first of all, you can say that, okay, a is greater than 0, so the shape is like that. Secondly, you can check b squared minus 4ac should be less than 0, which means not intersecting the x-axis. Okay, you can do that, then you quickly you can claim that this is all positive for value for that. But since I would like to determine the minimum value